This is the final lesson of the documentation chapter, and I think it's a fitting topic for the end. I want to introduce you to an alternative to the Swagger UI called Scalar, which has a very clean user interface, and I think it presents the information from the OpenAPI document very nicely. So let me show you how to configure Scalar. Scalar is kind of similar to Swagger when it comes to the setup. We have to install an additional NuGet package. So I'm going to look for Scalar, and the one I want to install is Scalar ASP.NET Core. Let me go ahead and introduce the latest version, and then how do we enable it? We need to point Scalar to our OpenAPI document, which is generated by Swagger, and the simplest way to do this is to say app map Scalar API reference and give it the pattern where it can access the OpenAPI document. Now here I'm specifying the version 1 document, which contains most of my API endpoints. And it's also interesting to note that this was actually designed to work with the endpoint exposed by map OpenAPI. So if you're using the built-in OpenAPI specification from Microsoft, then you just have to call map Scalar OpenAPI reference and everything is going to work out of the box. But because we are using Swagger, we have to tell Scalar where to find the OpenAPI specification. So now I can start my application and I need to navigate to localhost 5001/Scalar. And you should be able to see a user interface like this. This is the Scalar UI and it's rendering the documentation for the DevHabit REST API. You can see the server URLs, which is currently just localhost 5001. It's also rendering the authentication that we support, which is bearer authentication. And then if we keep scrolling, we can see the documentation for our API endpoints. So you can see that it's properly rendering the documentation from our XML comment. This is the endpoint summary and then the description. We can also see what to expect for the specific responses. If I had XML comments in the properties on this response, it would also be rendered here. You can see what to expect for different status codes, and then we can observe the documentation for the remaining API endpoints. We also have the ability to pick the media type that we want to use right from the user interface, and it gives you a small example of how to send a request to the specific API endpoint. This here uses curl, but you can use another tool, but it also has support for using many other tools like the HTTP client in .NET. So here's an example of how to send a request to the refresh endpoint using a .NET HTTP client. If I keep scrolling down, we'll see more of our API endpoints. Here are the endpoints for the entries and the respective documentation. Notice that for these endpoints, the media types are properly documented in the OpenAPI specification. What makes Scalar interesting is that it's a very good documentation format for distributing to your clients. You could host this as a static website, and anyone who wants to integrate with your API can navigate to the documentation file and take a look what are the endpoints that you support. Essentially, if I were to keep scrolling down, I would be able to showcase all of the API endpoints, but I want to get to the bottom. Here is my last API endpoint, and then we have the documentation for our request and response schemas. So for example, here is what the access token DTO looks like. Here's what a generic type is rendered like. This is the collection response that returns the entry DTOs. And this is the response from our API endpoint that uses cursor pagination. It returns a collection of entry DTO objects and also an array of hypermedia links for each of these objects, as well as an array of hypermedia links for the response itself. If I were to keep scrolling down, I'd be able to see all of the types that I support inside of the OpenAPI specification. And another thing worth highlighting is that it supports light and dark mode so that your clients get the full experience of your REST API documentation. And I'm going to wrap up this quick showcase of Scalar, which you can use for rendering your OpenAPI specifications. I demonstrated how to configure it using the Swagger document, and it's also going to work right out of the box with the OpenAPI specification generated by the Microsoft library. With this, we are also going to conclude our chapter about documenting REST APIs, and we can move on to our next chapter, which is going to be about deployment and monitoring. Welcome to the final chapter of the Pragmatic REST APIs course, where we are going to cover deploying and monitoring our DevHabit application. Here's a quick rundown of the upcoming lessons. We're going to start by quickly deploying the client application and making sure that we can access it through the internet. However, the client application won't be able to work just yet because we're still missing our database and the API. So we're going to deploy the database next. I'll show you how to make it accessible through the internet and how to apply database migrations and seed any initial data. Then we're going to deploy the REST API and piece everything together. We'll connect the DevHabit API to our database, and we're also going to connect connect the client application to the REST API and test out how our application is behaving in production. Another important topic that I want to cover is monitoring your application, and we're going to use Application Insights for this because it has an excellent integration with OpenTelemetry that we'll be able to easily configure inside of the DevHabit application. Finally, we are going to automate our entire deployment process using GitHub Actions. I'll show you how you can use it to deploy the client application as well as our REST API while also applying database migrations. I will be using Azure as my cloud provider, and this is where I'm going to deploy all of my services. We're going to use the Azure Static Web Apps to deploy the client application. We'll use the Azure offering for Postgres to deploy our database, and we'll use the Azure App Service to deploy the DevHabit REST API. Azure has excellent integration with the .NET ecosystem and is probably the best platform out there for hosting your .NET applications. It also comes with a lot of tools built in that are going to make our deployment process simpler, and it's also going to make monitoring and maintaining our applications in production much easier. Of course, Azure isn't the only cloud provider out there. You can just as easily deploy the entire DevHabit application to AWS or even on-premises on your own servers. However, Azure is what I expect most .NET developers to be familiar with, so that's what I'm going to use in the upcoming lessons. I think we are ready to move on to our next lesson, where we are going to deploy our client application that was built using React to an Azure service that is excellent for hosting single-page applications. In this lesson, I'll show you how you can deploy our DevHabit client application, which is a single-page application built with React, into Azure. We're going to use an Azure service called Azure Static Web Apps, and it does what you might expect it to. It's meant for hosting static websites, and single-page applications certainly fit this description. Static Web Apps also have a CLI that we can use to easily deploy our React application into Azure. Now let's jump into the Azure portal, and I'll show you how to set up the Azure Static Web Apps service. If you go into the Azure portal, you will be able to find the Static Web Apps service. You can also find it from the search bar by looking for Static Web Apps. Now, because I've already used it, I'm going to go ahead and navigate to Static Web Apps, and I'm going to create a new static web application. And now let me walk you through the setup process. You'll see it's surprisingly simple. For the resource group, I already created one ahead of time, and I'm going to choose DevHabit, and this is where all of the resources for my DevHabit application are going to live. Then I need to assign a name to my static web app, and let's call it DevHabit Client. You can choose your hosting plan, and this is going to determine your pricing. Now, because this is a very simple application, I'm going to choose the free plan, and we won't have to pay anything for our static web app. Now, when it comes to the deployment details, I'm going to choose Other because I want to be deploying this myself, and this will give me more control over the deployment process. If you don't want to, you could integrate this with your GitHub account or Azure DevOps, and this will set up an automated deployment for your Azure Static Web App. Now I'm going to choose Other and click Next. For the deployment configuration, I want to be using the deployment token, which is going to allow me to easily deploy my application from the CLI. When it comes to the advanced settings, I won't be choosing anything here. The region is going to be the same one that my resource group belongs to, so I'll just click Next. I'll skip over tags and head over to create my static web app. So let's click Create, and this may take a couple of moments, and you can see that my static web application is ready. So I'll go to my resource, and if I navigate to this address, I'll be greeted by a welcome screen, which is deployed by default, so our client application is functional. Now all we need to do is to deploy it. And for this, we're going to use a deployment token, which you can grab from the Azure portal. This is what it looks like, and we're going to need this value in a moment, so just keep it in mind. Next, I'll jump into my client application, which is a React single-page application that uses Vite as the build tool. So what do we need to do here? I'll open up the terminal, and I'm going to install a CLI tool. We can use npm to install this tool globally, and it is the Azure Static Web Apps CLI. So let me press enter, and I'm going to proceed to install this tool. Now, because I already have it installed, this is just going to confirm that I have this application, and in a couple of moments, my installation will complete. So now I'm going to clear this, and I can say SWA version, and this will give me the version of the Static Web App CLI that I have installed. Then we need to navigate to the root folder of our static web app, which is exactly where I'm at, and I'm going to use the SWA init command. This is going to initialize our project to use static web apps, and I'll choose a configuration name. Let's say devhabit UI, this is fine. It's going to automatically detect that I'm using Vite as my build tool, and it figures out what is the command to build or run this application in development mode. So I'm happy with the default settings, and I'm going to click yes. And you can see we get a couple of commands of what we can do next. You can do SWA start to run your application, SWA build to build it, or you can use SWA deploy to deploy your application. And this is what we are looking for. Now let me open up the SWA CLI config.json file. And here you can see just some basic configuration that is needed to set up our application with static web apps. So I'm going to clear the terminal again, and let's try to build our application. I'm going to say SWA build, and this should produce a production-ready build of my client application. You can see this completes pretty fast and is going to output the files that we need into the dist folder, which you can see here, and it contains a couple of static assets. So now that I've built my application, I can go ahead and deploy it. I'm going to say SWA deploy. For the environment, I'll specify production, but if you want to, you could also deploy this to a development environment. And the second argument we need is our deployment token. I'll quickly jump into the Azure portal, and I'm going to copy the deployment token, and then I'm going to paste in the value for my deployment token, and I should be able to execute this command, and this will kick off the deployment process of my client application into production. Now this usually completes pretty quickly. It takes under a minute to get your application deployed, and I like the simplicity that we get with the static web app CLI. When the deployment completes, we'll be able to access our application from the URI, which if I click, will be navigated to the devhabit application that is now hosted on Azure. So we have successfully deployed our client application. Now we do have a couple of problems. Let me open up the developer tools, and I'm going to input a dummy username and password and try to sign in to my application. And you will see that I'm sending some API request, which is going to fail. And this is because the request is being sent to my API that is running in localhost. And we obviously can't use this in production. So we're going to fix this when we deploy our REST API in one of our upcoming lessons. But for now, I just wanted to show you how you can easily deploy the devhabit application into Azure. And now let me show you how we actually configure the API URL. Back inside of VS Code, if I open up the environment file, this contains the environment variables that I'm using locally. You have to prefix them with Vite, and the environment variable name is API base URL. I can reference this from my code to obtain the URL pointing to my API. Now you can see that this is configured to target localhost. We'll have to update this value once we deploy our REST API to target the correct value. Of course, I'll also show you a better way of how we can pass in environment variables when we build the automated deployment pipeline. And with this, I'm going to wrap up this quick lesson about deploying the devhabit client application into Azure Static Web Apps using the SWA CLI tool. In our next lesson, I'm going to show you how we're going to deploy our database. Remember that we're using Postgres, and we'll also have to apply our database migrations and seed some initial data.